Alright, today we're looking at Chapter 4, Topic 8, Day 1 lesson, which is solving quadratics by factoring. So this is very similar to what we did with factoring, and this is primarily why we had to get so good at factoring, is so that we could solve these quadratics by using factoring to do this. And the way that we do this is to first put the equation equal to 0. So it has to have everything on the left side. And then, oopsie, whoa, what is this? Everything on the left side, so ax squared plus bx plus c, and on the right side has to be 0. Make sure the first term is positive, check for the GCF and factor, so all of that is the same, and that's going to occur on the left side. And then we're going to get two factors, and we're going to set those two factors themselves equal to 0 in order to solve by using the zero product property. What the zero product property says is that if you have two things, A times B, and their product is 0, then A is equal to 0 or B is equal to 0. That should make sense. If they're multiplied to be 0, then one of them has to be 0. And that's going to be the idea when we find the factors, because if you have two things, if you have something, two factors multiplied together equal to 0, then either of the factors could be 0. So when we're factoring here, keep in mind, when we're looking for the zeros, we're looking for the roots, we're looking for the solutions, these are all the same thing. Roots, zeros, and solutions. This is also going to be where our graph passes through the x-axis. Okay, so these solutions that we're finding to these equations also represent where these graphs, well, where this graph, ax squared plus bx plus c equals y, would pass through the x-axis. Okay, these solutions are x-intercepts. They have a lot of different names. They have roots, zeros, solutions. They're also x-intercepts. It's actually, whoops. It's actually done pretty simply. So let's take a look at number 1. 16x squared plus 8x equals 0. So we have our initial conditions met. The right side is 0, so that's all we need. First, we're going to start by factoring out the GCF. On the GCF of these two terms is 8x. 8 goes into 16. Well, let's see. 8 goes into 16 2 times. X goes into x squared x times. And 8 goes into 8 one time, and x goes into x one time. So what we get when we factor out the GCF is 8x times 2x plus 1. All right, well, neither of these can be factored anymore. 8x certainly can't be factored, and 2x plus 1 certainly can't be factored either. So what we're going to do, these would be the two factors. 8x would be one factor, 2x plus 1 would be the other factor, and they multiply to be 0. So what that means is that either 8x is equal to 0, or 2x plus 1 is equal to 0. If we can solve these two equations, we can figure out which x values result in this being equal to 0. So, and those would be our solutions. So if we divide by 8, we can see that one of our x values that satisfies the equation would be 0, x equals 0. And if we solve this other equation, we see that our other x value that satisfies the equation, or that is a solution to the equation, is x equals -1/2. So here we go, we have two solutions because remember we typically have two x-intercepts because, well, sometimes we have two x-intercepts because remember we're looking at quadratics, which are parabolas. They look like this. So they are going to sometimes cross through the x-axis 2 times. So this would be saying that this graph crosses through the x-axis at 0 and at -1/2. and those would be the two solutions for number 1. Most of these will have two solutions, but not all the time. All right, if we look at number 2, well, first of all, the right side is not equal to 0. It needs to be equal to 0. So let's bring that 1 to the left side by subtracting it. So we get 25x squared minus 1 equals 0. All right, we can check for the GCF. There's no GCF here. We also can't factor this normally because this is a difference of two squares. Squared minus squared. So this is not a normal factoring problem. This is a difference of two squares. 5x squared, because 5 squared is 25, and x squared is x squared. And then 1 squared, because 1 squared is 1. So remember what difference of two squares says. It says if you have x squared minus y squared, that factors into x plus y, x minus y. So this will factor into 5x plus 1, 5x minus 1. Okay, well, I have my two factors. So this factor times this factor is equal to 0. So that means either this factor is 0 or this factor is 0. So we're going to set up two equations where each factor could be 0. And then we're going to solve them. So one of our solutions, we're running out of room here. One of our solutions, we subtract 1, then we divide by 5. One of our solutions is negative 1/5. Negative 1/5. Our other solution we would get when we solve the other equation so we add 1, divide by 5. So our other solution is 1/5. So we got two solutions, negative 1/5 and 1/5. Sometimes you may see this as a set of solutions. You may see it in these curly brackets. This just means that it's a set of solutions, such that our set of solutions includes negative 1/5 and positive 1/5. So you may see it like this as well. These answers are fine. This one's fine too. All right, let's look at some more. All right, so number 3, we have x squared plus 16 plus 64 equals 0. It's equal to 0, so we don't have to worry about that. The GCF is 1. There's nothing to factor here. So x squared plus 16x plus 64, I will have to factor normally using the x. However, the a value is 1, so I can use the shortcut here. Okay, I don't have to go through the grouping part. I can just use the shortcut because a is 1. So up top is a times c, so that's 64. Bottom is b, that's positive 16. Two numbers whose product is 64 and whose sum is 16 would be 8 and 8. And since a is 1, I can just use those as my factors, x plus 8 and x plus 8. So this factors into x plus 8 times x plus 8, or just x plus 8 squared, equals 0. Well, in this one, I only have one solution because both these factors are the same thing. So both these factors give me one equation, x plus 8 equals 0. All right, even if I had written this twice, I'd get the same thing. They'd both be x plus 8. So I'm only going to have one solution here. That solution is negative 8. So this problem, number 3, only has a single solution, as opposed to two solutions like we saw before. Number 4, it's not equal to 0. It's a problem. So let's get the 20 onto the other side by adding it. So we got x squared minus 9x plus 20 equals 0. Alright, now it's equal to 0. Let's check for the GCF. It's 1. Let's factor. So we'll use the x. Since we see that a is 1, we can skip the grouping portion because a is 1, which means we can just take a shortcut. So up top is a times c, which is positive 20. The bottom is b, which is negative 9. Two numbers whose sum is negative 9 and whose product is negative 20, negative 5, and negative 4. Since this is a equal to 1, means that we can use these as our factors, x minus 5 and x minus 4. So this would factor into x minus 5 times x minus 4 is equal to 0. Alright, well it says that these two factors multiply together to make 0. So either this factor is 0 or this factor is 0. So I'm going to set them both equal to 0. Either x minus 5 is equal to 0 or x minus 4 is equal to 0. Essentially, I'm asking the question, what number would make this factor 0? And what number would make this factor 0? Well, of course, 5 would make the first factor 0. Okay, because 5 minus 5 is 0. And what number would make the second factor 0? Well, 4 would make the second factor 0, because 4 minus 4 is 0. So my two solutions are 5 and 4. And you may see it as a set, 5 comma 4. That's a set of solutions. That's a set that includes the numbers 5 and 4. And those are the only two solutions to number 4. And we found those solutions just by factoring. Alright, so solving quadratics by factoring. Make sure you show the work, page 49, 13 through 18.